All right, so today we're looking at use similar triangles to solve problems. This is the third day reviewing this topic. So hopefully by the end of today, you've grasped the intro to trigonometry and similar triangles, proving why they're similar, and also knowing the intricacies of a scale factor, what it reveals in terms of the relationship between side lengths of two similar triangles, and how we can use the scale factor squared to compare the areas of two similar figures or two similar triangles. All right, so triangle ABC is similar to triangle PQR. The ratio of their corresponding sides is 3 to 8. So that is the scale factor in essence. We can use that ratio to find the scale factor. Which of the two triangles is the smaller one? We're going to say triangle ABC because the relationship is 3 to 8. We're comparing it that way. What is the scale factor that relates the larger triangle PQR to ABC? That would be the larger divided by the smaller. I think it's equal 2.67. But let's just double check that quickly. 8 divided by 3. So 2.6 repeating, so 2.67 if you want to round that. Then it tells us here that the area of triangle ABC is 50 square centimeters. Actually, let's go back here and answer the question why. I just realized we have this question why. Which of the two triangles is a smaller one? Why? Because they're in the ratio 3. They're in the ratio 3 to 8, and because we're relating the ratio of triangle ABC, we're saying triangle ABC is similar to PQR, and that their corresponding side lengths are 3 to 8. We're writing it in that same order. So triangle ABC side length, if one side length of triangle ABC is 3, and in the larger similar triangle, then the side length would be 8. Okay, so that's why that is that. All right, the scale factor is usually the larger one, the larger, divided by the smaller. That's how we calculate the scale factor, okay? Because we want to know what we multiplied the smaller by to get the larger similar triangle. If the area of triangle ABC is 50 square centimeters, that's the smaller triangle, keep in mind, right? We're given that up here in the question above. If that's the smaller triangle, what is the area of the larger triangle? We learned last day that the area of the smaller is equal to, sorry, I apologize, area of the larger is equal to the area of the smaller triangle times k squared. So what we're going to do here is fill in what we know. We know the area of the larger triangle is going to equal the area of the smaller one, which is 50, times 2.67 squared. And it's going to equal, let's just do that, squared, 50 times the scale factor squared. So 355.55. So we're going to say 355.5 repeating square centimeters. That's how we calculated that. Okay, all right, go ahead and erase this just so we have room for the next question. All right, what is the ratio of their perimeters? So what I like to usually do for questions that you may find a struggle with at first is to use a simple example. So let's just make up a triangle, a simple right triangle. Let's say it's 3, 4, 5. Then we're going to create our own similar triangle, and we're going to say this is 8, 10, and 6. So we know that the scale factor is 2 because 6 divided by 3 is 2. 8 divided by 4 is 2. 10 divided by 5 is 2. So the scale factor is 2, k equal 2. And the perimeter of the smaller one, I should label it just so we know what we're talking about. Let's call this A, B, C, and let's call this D, E, F. And so we know that the perimeter of ABC is equal to 3 plus 4 plus 5, so 12 centimeters. And the perimeter of DEF is 24 centimeters if you add them up. So we notice that the perimeter is twice the perimeter of the larger one is twice the perimeter of the smaller one, and the scale factor is also 2. We know that. That seems pretty logical. Because we've doubled up every side, then it's going to have double the perimeter. Obviously, that's different for area, so watch out for that trap. You may get confused with the area that we just covered. So in this case, the ratio of their perimeters for the ones we're talking about is really 2.67 to 1. The ratio of the larger to the smaller is 2.67 to 1. Right? All right, or the scale factor. The areas of two similar triangles are 560 square centimeters and 1260 square centimeters. What is the ratio of the side lengths of their corresponding sides? The ratio of the side lengths of their corresponding sides. What it's asking you really, if you take a look at the very first question in review, the ratio of their corresponding sides, in this case is 3 to 8, what it's really asking you is, do you know the scale factor, or K? Now, we remember, like I just explained to you, the area of the larger triangle is equal to the area of the smaller triangle times the scale factor squared. So the area of the larger one here is 1260 square centimeters is equal to 560 times k squared. What we want to do is isolate k. So first step is to divide both sides by 560, and we end up with k squared equal 1260 divided by 560. So k, of course, is going to equal the square root of whatever 1260 divided by 560 is. And k is going to equal whatever we're about to calculate. So we're going to find out the square root of 1260 divided by 560. And that's 1.5. So the scale factor here is 1.5. Or we can say the larger to the smaller is 3 to 2, or we could say 2 to 3. So it's 1.5 or 3 to 2. Okay. That's it. Actually, I think I feel more comfortable saying 2 to 3 here. 2 to 3. The larger divided by the smaller would be 1.5. Okay. It asks us for the ratio, so we're putting it in ratio format. Why not? Here's a question that I'm going to ask you to do on your own, really. It's telling you triangle ACD, the entire large triangle, is an equilateral triangle. Point M is the midpoint of the side CD. Okay, so we know point M is a midpoint. Fill in the chart below. So you've got a chart in your handout, and I want you to fill in all the respective side lengths. The only hint I'm going to give you is you're going to be using similar triangles, and you may have to use, just again as your extended hint here, you're going to have to use this triangle here, which is triangle ACM, and you're going to also need to use triangle ABX, and you're going to have to use that information from those two and the information given here in the diagram to help solve all of these. And that's something we will definitely review in class, but I'd like you to try that on your own and see who can in fact figure out which triangles are similar, prove their similarity, and then of course go ahead and fill in the chart. I will talk to you in class. Hope that helps.